All right, hey you guys, how's it going today? We are looking at topic 8 on linear functions, and we're going to go to 8.3 on initial value. Not a whole lot as far as examples are concerned that I can actually access here, so I'm going to go ahead and slide it right down to the homework piece, and we'll do a handful of problems here. Again, I don't think you're going to have much value, or much difficulty, I should say, in understanding the concepts here. When I talk about finding the initial value, all that means is you're going to let x equal 0. And if you do that in every one of these problems, you should be just fine. So in this particular case, if I say, hey, I'm going to let x equal 0, 5 times 0 plus 9, if I were to plug it all in, my final answer is going to be y equal 9. And you can see here, I should be good to go if I simply plug in 9 as my final answer. Okay. Any questions with that? Move on to the next one. Linear function has an initial value of 3. So if we're looking at an initial value of 3, we're going to basically plug in 0 for my x once again. Obviously, if I plug in 0 here, I'm going to get 4, so that's not it. If I plug in 0 here, I am going to get 3, so that would be it. This is going to be negative 3, and this one's going to be negative 4. So the linear function that has a initial value of 3 should be y equal 4x plus 3. All right, moving on to problem number 3. Find the rate of change of the linear function shown on the graph. So this is the second aspect of this that they're going to look at. They're going to be able to ask you, hey, find the initial value. Well, obviously the initial value in essence should be your y-intercept. So if you take a look at this point right here, it appears as though my y-intercept is negative 2. That's where x equals 0. So if I plug in negative 2, whoa, I'm sorry, just looking for the rate of change. I didn't read that correctly, my bad. So if I'm talking about the rate of change, then we're looking for the slope. So if I look at this and say it goes through this point right here, and it goes through this point right here, then the slope should be up 1, up 2, up 3 over 1. So it looks like the slope should be positive 3. Remember, we're doing rise over run. That's got a forward lean to it. And so since it has a forward lean to it, then obviously we're going to get a positive value. So let's go 3 here. There we go. And then the initial value, which I've already answered, should have been negative 2. Again, that's where we're crossing the y-axis. All right, move on to problem like number 5, possibly. Number 5, it says we have a hot air balloon. They're giving you height is in h, and t is the time in minutes, and how high was the balloon when it began to descend. So again, you're just interpreting the graph at this point. When it began to descend, you're looking for that location right here where it started going downward, and it appears as though the answer is 75 meters. So in this case, you're looking for, again, the initial value. All right, so that's pretty much what you're going to see here. I don't anticipate too many difficulties. Obviously, if there are some, feel free to shoot me an email. But I think for now, we should be sitting pretty good on 8.3. I'll go ahead and stick 8.4 on this same piece since I'm only about 4 minutes in. Thank you. Have a great day. All right, we're back here with topic 8, linear functions, and we're taking a peek today at 8.4, comparing two linear functions. So once again, we're going to dig into the homework, go straight to the homework in order to pull some of these example problems from you, or for you. And you're going to see us investigate. You're going to see it in an equation form, you're going to see it in a table form, you're going to see it in a graph form. It says which linear function has the greater rate of change, the one described by that equation or the one described by the table. Now, once again, when I'm talking about rate of change, okay, we need to be thinking about slope, all right? And so if I look at this equation, the equation here that we're talking about is y equal 3x plus 4. So the rate of change that you should be identifying with should be this 3 right here, okay? So that 3 represents the rate of change on that one. If we take a look over here at the table, at that particular linear function, we would see that we have to take a look at our rise over run. And in our situation, rise over run is what? We go up 8, and we go right 2. Okay? And again, remember how I'm getting that. I'm going from 4 to 12, so that's 8. I'm going from 1 to 2, oops, which is really only 1. Okay, so my slope, geez, my slope here should be 8 over 1, which is a slope of 8, or a rate of change of 8. So the rate of change here is 8. The rate of change here is 3. So obviously the second one has the greater rate of change. Okay? Move on to problem number 2. On problem 2, the linear functions model the score in the second round. The function here is 4x plus 5. So the rate of change here is going to be 4. And over here, if we take a look at my table, we see that we go from 7 to 9, which is a rate of change of 2. So remember, in a table, this is your y value and this is your x value. So 2 over 1, so the rate of change in the table appears to be 2. So obviously that means that the linear function, let's see, the linear function y equals 4x describes player A gain more points in this round. Player A gains more points than player B does for each correct answer in the round. Remember, x is the number of questions answered correctly, and y is the score. So that means what? D? Questions there? All right. So again, you're comparing functions in different formats is in essence the focal point here. Same idea here. 2 athletes training over a 2-week period to increase the number of push-ups they can do consecutively. Athlete A can do 14 to start and increases his total by 2 each day. So athlete A, you're thinking, all right, their rate of change is 2. Okay. If you look over here at athlete B, he's charting his on a table. And so athlete B looks like every day he goes up by 3. Again, this is changing by 1. So obviously athlete B is 3, has a rate of change of 3. Compare the initial values for each. Choose the correct answer. The initial values are equal. The initial values, so A can do 14 to start, and B can do 15 to start. So athlete B has the greater initial value. All right. Moving on to number 4. Like the last one I'm doing, there's only 2 parts of this. So a linear functions model, the temps on Tuesday and Wednesday. On Tuesday at 7 was 57 degrees Fahrenheit. So Tuesday, 57 was your starting point. The temperature dropped 5 degrees each hour until midnight. The function T equal 58 minus 4H model the temperature on Wednesday. The temperature T is in degrees Fahrenheit. H is number of hours, and 7. What do the initial values of the functions tell you? The initial values of the functions, which in Tuesday's case would be 57, and in Wednesday's case would be 58. The initial values tell you that the temperature at midnight was less on Wednesday than Tuesday. That's not true. Temperature was less at midnight than it was at 7 for both days. Temperature at 7 was less on Tuesday than Wednesday. if that's the situation that we're looking for. C. All right, and I gotta believe they're gonna come off of those with some other avenues, so that's gonna make you think a little bit. All right, that's your difference for 8.4 then. Shut her down there, maybe stick 8.5 on here yet. Okay, we're back. The final section of chapter 8 that we're going to be talking about, 8.5, talks about constructing a function to model a linear relationship. And again, we're having trouble for whatever reason with the examples here, so we're going to go straight to the medicine and pop in some of these homework questions, which should be advantageous to you if you're watching this. At time 0, water begins to drip out of a pipe into a bucket. After 52 minutes, there are 13 inches of water in the bucket. Write a linear function rule to model how many inches of water are in the bucket after any number of minutes. So in essence, what we're trying to do is we're trying to create a situation. We're trying to create an equation, all right? And you got to be thinking here, y equal mx plus b is your base equation. So at time 0, water begins to drip out of the pipe in the empty bucket. After 52 minutes, there are 13 inches of water in the bucket. You have to write a linear function rule in order to model that situation. All right, so in order to think about this, we need to be trying to think about the constant of proportionality. The constant of proportionality is also the slope and is represented by y over x. So if we take a look at the fact that y is likely the time, I'll think about that for just a second, where w inches of water in the bucket after t minutes. Okay, and so we're actually dealing with w and t here as opposed to y and x. So after 52 minutes, there are 13 inches of water in the bucket. Okay, so what do you guys think? Do you think we're going to go 52 over 13, which would mean that what? About 4 inches of water per minute? Or would we go 13 over 52 as our COP, which would represent what? 1/4 in that situation. So let's go W equal 1/4 times T. 1/4, you guys say to use tab here, times T, and we're good to go, okay? So that's the equation that we would be looking for in order to create that scenario, all right? And again, before you plug that in there, one of the things you might want to do is you might want to, once you have your equation, W represented what? The water, inches of water, so that would be 13 equal 1/4 times the time in minutes. Does that equal 13? Yes, it does. And so I would check it, obviously, since it's a single shot especially, before you pop that in there. Okay? Again, remember, T equals 0, so you obviously know that your starting point, you have no y, the y-intercept is going to be 0. All right, let's take a look at the next question. A car moving at constant speed. Pass a time device at t equals 0. After 9 seconds, the car has traveled 1,026 feet. Write a linear function rule to model the distance the car traveled in d feet, and the seconds would be time. All right, so d equals some number times t. All right, so you got a constant that's going to be going into that box. Now remember, we said that this constant is the same thing as the slope. Therefore, if you divided both sides by t, you would be able to get that box. So this box could be calculated by simply saying, hey, I'm going to divide this thing by t. I'm going to divide this thing by t. The t's cancel out, so box equals d divided by t, and that represents your constant of proportionality. Okay? So if we take d, which in this case is what? 1026, and we divide it by t, which is 9 seconds, we should have our constant of proportionality in that scenario in order to make this work. So 1026 divided by 9 is 114. So we are saying that our initial equation should be d equal 114 represents our COP, our slope, times t. So 114 t. Okay? All right. Next question, question 3. Food festival charging admission for each sample food. Admission and 4 samples cost $6.25. Admission at 8 samples cost $10.25. Write a linear function to model a cost for any number of samples. Okay? So 4 samples, $6.25. 8 samples, $10.25. Right? So one of the things that we need to be potentially thinking here is, if I plug in 4, I get $6.25. It's almost like you could look at it as an ordered pair. And if I plug in 8, I get $10.25. So if we take a look at that, and the first thing we're trying to say is, hey, we need to have a linear function rule. We're looking for y equal mx plus b. And since we're looking for y equal mx plus b, we're going to first of all have to find the slope, right? Well, the slope is what? 10.25 difference in y over difference in x over 8 minus 4. So it looks like our slope is going to be 4 over 4, which is just 1. Okay, so our slope is 1. When I plug that in, y equal 1x, I really don't even have to do that. Could just put in x plus b. Go ahead at this point and plug in any of the x values or any of the y values. So I'm going to choose to use the first one since the numbers are smaller. Okay, I'm going to say, all right, y was 6.25, x was 4 plus b. Trying to find the y-intercept here. So I subtract 4 from both sides, and I get b equal $2.25. So my initial value was $2.25. So my final equation then should be y equal x plus 2.25. X plus 2.25. Okay. Good to go there. Hopefully. It's going to be a little stronger, a little tougher, it looks like, than the previous 2 sections. All right, so make sure you have a little patience here. Again, we've done this type of one before, where we first of all need to find the slope, and so we would look at this and say difference in y over difference in x. I'm going to take 24 minus 20, and I'm going to take 7 minus 3. Make sure you have them in the same order. Again, I get 4 over 4 equaling 1. So my slope is just 1. So I know my format, which is y equal mx plus b, is looking at y equal, I'm going to go ahead, m is being replaced by the number 1. So if I replace x here with one of these, so I'm going to go 3. All I did was replace x with 3, plus b. I'm going to go ahead and scratch my y out, grab my y from up here, so that's 20. So it looks like if I subtracted 3 from both sides, my y-intercept is going to be 17. Therefore, plugging this back into this equation, my final equation should read y equal x, again there's no m, the m is a 1, I'm sorry, plus 17. So let's see if that works. Y equals x plus 17. Boom. Okay. You're going to have to probably work on that one just a little bit if you're finding some issues there. Let's do one more. Time 0, water begins to drip steadily out of the tank. After 3 hours, there are 5.8 gallons of water in the tank. After 8, 3.8 remain. Write a linear function that models. Now, one of your things that you're going to have a little issue here with is you are losing water. So whatever your rate of change is going to be a negative number. So we're dripping out of the tank. After 3 hours, there are 5.8 gallons of water in the tank. After 8 hours, 3.8 remain. So once again, in essence, you could say it's 3, 5.8 if we looked at it from the standpoint of a ordered pair, and you're going to move to 8, 3.8. So if we go difference in y over difference in x, once again, difference in y over difference in x, we're going to get to, we're going to go ahead and go 5.8 minus 3.8, and then I have to start here, remember, I'm going to go 3 minus 8 right there. So it's going to be 2 over negative 5. So my slope is actually negative 2/5. Okay? Or if you wanted to, you could say my slope is, since it looks as if they were giving it to us in decimals, you could say negative 4/10. Okay? So we know that we're at y equals negative 4/10 x plus b. We then have to plug in one of those ordered pairs, and I'm choosing to plug in the first one, so I'll plug in this guy right here. And so I'm at y equals, so this is going to be 5 8/10 for y, equals negative 4/10 times 3 plus b, which is 5 8/10 equals negative 1 2/10 plus b. I'm going to add 1 2/10 to both sides, and that's going to give me b equal to 7. All right, so knowing that b equals 7, that's my y-intercept. My final equation to me should look like y equal, the slope we had was negative 4/10 x plus b, which appears to be 7. All right, let's pop that in and see where we stand. Negative 4/10 x plus 7. We're good to go. All right, I know it was a little bit long, so we'll shut her down at this point. But remember, the 24 minutes that we're using here, we're encompassing 3 lessons. All right, have a good one. Good luck.